So I just want to show an example involving the root test. In general, the root test is going to work when you have an entire expression. When the series definition has an entire expression being raised to a power of n or something involving n. The reason the root test is kind of limited is that we don't really have a theory of how to find the root of a factorial. And as to if we have functions that involve different powers of n, it may be difficult to simplify. But if you have everything if you have everything in the expression being raised to one power of n, then the root test tends to work pretty well. So what we can do here is we're going to write that we're going to use the root test, and we're going to calculate the limit as n approaches infinity of the nth root of the absolute value of the general term. Let me get this right. So I'm taking the general term and putting it in absolute value bars. Now, of course, the way that you would calculate this really is to take absolute value of n over 2n plus 3 to the n and raise that to the power 1 over n. That's the same thing as taking the nth root, is just raising to the power 1 over n. Since what you can see is this series in here is already positive, I can take the absolute value out because I'm only getting positive terms anyway. So that's the limit as n approaches infinity of this is going to be n over 2n plus 3 to the n to the 1 over n. Now I can very directly just multiply the exponents together, and that equals the limit as n approaches infinity of n over 2n plus 3, because n times 1 over n is just 1, so essentially that becomes a 1, and I can just take it out. This, using the trick where we recognize the highest powers of n in the numerator and denominator and just use their coefficients, this limit is going to be 1 half. 1 half is less than 1, and therefore we can write that we know that under the root test, that since we got a limit that's less than 1, the series converges absolutely. And if it converges absolutely, we can say, therefore, it converges. Because even though converge, why is it doing that? Converge absolutely is a slightly different conclusion from converges. We know that by the absolute convergence test, if a series converges absolutely, then it converges.